All right, so just a couple more things about the version control. Okay, last time I did mention about how do you clone and then start creating your local repository. I told you how you can push or change from local to remote by going through this kind of command. I also told you how you check your status, and the most difficult part is how do you synchronize your code repository and also merge or change. So these commands are the ones I normally use. As I told you, when you try to sync the repository, you can just do something like git pull to pull all the latest changes. After that, you combine everything, you make another push. Okay, but another one is something called pull dash rebase. To be honest, I can't explain the difference. I can't explain the difference in the technical term. I know the difference because this one will get you extra like a commit history in the repository, and this one won't. That's why I always prefer to do this one. All right, but you can take a look at some documentation to see the fundamental difference. And I don't think this one is always better, but most of the time it's better. All right, and also these ones also are based on the way you do all the rebase. So again, there are all different ways to do this. This is not the only way you can use, but whatever you can find or whatever you can understand, just follow that approach. And for Git, again, for the same thing, you often can find different command to do it. Like you don't need to know all of those and all the difference. You just need to find a way that you feel more comfortable and then you're very familiar with. Now, one more concept is the branch. And this is the kind of a concept most version control tool will have. All right. So normally when we are trying to push the things to the repository, we're pushing everything to something by default called master branch. So that is a default major branch we use. But then you can also create extra branches to push our things to a different branch. All right. So first of all, a branch is just like an extra copy. Okay, so you got one copy of your code right here, but you can create another copy and in a different branch. So when you try to push our code, you can try to push either to the master branch or a different branch. So why do we want you create extra branches? A major situation of doing this one is this. So normally when you try to push something to the repository, you want to make sure you finish the complete feature. So for example, I'm adding and updating the README file. I'm done, I'm pushing it, and then you should just go to master branch. Because that one takes you very little amount of time and you can get that done very quickly. But sometimes you will need to work on a bigger feature. Let's say you need to redesign and recreate the whole homepage for the application. And that whole project or that whole task probably takes you 2 weeks. During that 2 weeks, you probably will need to have a series of changes. You change the UI, change the layout, change the JavaScript, change maybe some of the font type, all of this. Every day you're making continuous progress. So every day you're getting some new code. And if you are actually pushing all this little code every day, by the end of the day, now you can push it to master. However, once you push the master, you're going to have a lot of the uncompleted feature or code there. Sometimes it doesn't matter, sometimes it does matter, right? So you may be only halfway done with the homepage, but then if you push that one, then people are going to have this halfway done homepage. So that's not good. So that's when this branch can be used. So you don't want to, affect this major master branch before you are done. You can push that to an extra copy, an extra branch. Sometimes we call it the feature branch. You can push it there so that it doesn't really affect the master branch. 2 weeks later, you complete done with your feature, and then you can do something called merge. You can merge this change back to the master, and that time, the master will have everything, up to date. So that's the reason why you have the branches. Okay, so mostly for the larger features that you cannot really do it finish right away. Or sometimes people use that one for some testing purposes. So we're making some changes. We're not sure if that's good or not. So I don't want to affect the master copy. I can just use this one. So in other words, I think the feature branches mostly serve as a kind of a backup for your another level of backup for you. All right. But however, in general, I would recommend that if it's a complete change, you're done, just go to the master. Don't bother to create every single change into a branch, okay? Because once you create a branch, you still have to merge it. The moment you merge, and then the master might have changed a lot, you still need to do all the synchronization, all the config resolving, and it's sometimes just extra trouble. But if you keep constantly pushing things to master, keep updating the master, synchronize that with the local copy, I think you will just need to have to face less conflicts. So that's all we prefer. All right. So just keep that in mind about the branch. Speaking of the branch, one more thing to mention is in GitHub, you have something called a pull request, right? So this is the feature not from Git, but from GitHub, right? So if you go to any kind of repository, and then what you can do, you can fork this repository right here. So that's going to give you another copy of this whole repository into a different GitHub account. And then you can make your changes to there, and you will own that copy if this one is public, or you have the permission to fork it. And then, but then one day you say, I want to contribute something back to this project. So you can then create something called pull request that you can then send a request to this repository, and that this repository will accept it or not. Okay, so that's a very cool feature from GitHub. The major motivation behind this feature is they allow the open source project to be very easily managed. For example, you got a project, somebody else want to contribute on your project, but you don't want to give the right permission right away to a stranger you never know, and you don't even know whether he or she can do it or not. So what she can do, or he can do, is fork to the project and then finish a change, and then he will send back a pull request. You can review that before you accept it. If you do accept it, it will be merged back to this project. So that is just a feature specifically designed for open source project to ease the communication and to ensure the safety about all the contribution. However, for our project, since you guys are the same team, you don't need to bother to create a bunch of pull requests. Okay, it's too much. You can do that. I see the student do that, but it's really not necessary. I don't think that's a purpose for this team collaboration. In general, you should just all keep pushing to master. Don't even worry about it. Not even the branch, unless you're doing something that's very, very experimental, very uncertain. So you can use a branch. All right, so that's something I want to comment on the branch and the pull request. All right, so at the end, I want to mention that another important thing about Git is you need to know how to undo things. All right, especially when you're trying to adding things. You add something, you realize, oh, I shouldn't add this file. I don't want to track the change. How can I undo it? I commit something, oh, how can I uncommit it? I don't want to push this one to the remote. Or you actually push something, how do you go back? Right. So these are really important steps. I didn't list all the commands because I can't remember them. Normally what I do is Google it. Google how to undo git add, how to undo git commit, how to undo git push. You will find the relevant posts and tell you how to do it. All right, so just do it by Google. But whenever things happen in Git repository, sometimes you mess up stuff, you'll find out there's no way to get it back. All right, the most important advice is, first of all, make a complete copy of your code. Don't lose it, because there is a chance that you will totally mess up the whole repository. Secondly, you can always just reclone the repository and copy the things over. So that's some of the practice you should keep in mind when you start to use Git initially. All right, but most of those problem happens after you synchronizing the code. If you are just pushing to one repository by yourself, you shouldn't expect any issues. All right, so knowing how to do the undo is important. Just Google the solution, and also before you after you back up your stuff. And then there's so many resources about Git. Okay, the Git tool itself is really complicated. There's a whole book talking about Git. All right, but I don't see any point for you to read a book before you're using a Git, because most of the commands you're using are just clone, add, commit, push, pull. That's every base. And then plus also the status log. These are the ones you use very, very often. I would say that 95% chance you're using this command. So just know the basic that's enough. You don't need to know everything about Git. That's once even you read a book, it doesn't really matter too much. All right. So any questions about Git and our version control? All right. So I'm going to talk about one more topic today. Okay. So this one, and we are going to look at the build tools. All right. So after talking about version control, another very important concept about a tool or kind of a method you use every day as you work as a software engineer is how do you build your software? Okay, any kind of project or company, they will use a few different build tools. And what is a build tool? All right, so these are very, very practical topic. And in general, you don't use this one at school, right? The best examples is if you are going to write a Java code, you more than likely you open an Eclipse or IntelliJ, create a project, type your code, click on the run button to run it. That's how you run things most of the time. You don't really need to use the build tool, or the build tool had been embedded automatically by those IDEs. However, from day one, you start working on a big company, and you will find that the text itself they gave you isn't too difficult most of the time. The logic is very straightforward. You're not going to touch very complicated algorithms. However, the tool, the environment they're using, and it's going to be very, very overwhelming for you to learn. Right? And you start to realize that any kind of code, you can't easily run it inside the Eclipse by clicking the button. Most of the code, you can't really run that way. You have to go through command line. You have to go through a long build process before you can run it. That's the part that I think for most of the junior engineer is something that you have to understand and get over it as quickly as you can. Otherwise, it's very difficult for you to contribute to the team. All right. So these are the major things that the build tools will help you to manage. So they will manage the life cycle of the development. We'll talk about that. It will manage the dependencies, really important. Okay. Others, they will manage, for example, some of the plugins you use for the tool, and then also like a conventions, standards, some of those. Now here is a more detailed list of the function you can do with the build tool, even though you're not using all of those. But for example, some of the what will be the example? For example, the release manager, control the version of the release, how to deploy stuff, right? And you got a Kickstarter project, kind of a bootstrap project template, all of those. These are falls into the function of the build tools, right? This the build tool can do. So I want to focus on these 4 important things about build tool. Okay, so you don't obviously need to understand all of those, but in my experience, when I was working in the companies, this is a major thing you need to understand about why are we using build tools. All right, it's about how you manage a standardized project structure. How do you manage the dependencies? Really important. And how do you really package your software, and eventually how do you manage the life cycle? Okay, any kind of build tool, if you can focus on these 4 different things, and that's enough. All right, so let's take a look at the first one, this project structure. All right, so we want to have a standardized project structure to manage our project. The reason is because the project files could grow and can be really huge and complicated. All right, so let's just open Eclipse, for example. Now this project here isn't really huge, but it does have a bunch of packages, as you can see, and then it does have different folders for different things. This one has a lot of web stuff. This one has templates. This one has JavaScript. Also, we got all our dependencies in this folder. We got some other files. All right, so this is a very standard way to manage all the project files. However, if you create a project from scratch, for example, this one, right? So this is the Java project I created by default from Eclipse. It only has one source folder, that's it, and then you create all the files here. All right, so you can still run it, no problem, but if you grow the project with more Java classes, web pages, JavaScript files, then you have to create all those folders by yourself. But if you use a build tool, for example, in this case, we're using a tool called Maven. So we'll talk more about Maven. And it will automatically create this standard package for you. Okay, let me give you an example. So I'm going to go to Eclipse and create a new. I choose a project. I'm going to create a Maven project. So Maven is a Java build tool. It's a very popular tool that being used very widely in the industry. All right, so you're going to specify all the position where you save it. And then here you can choose some kind of a template. So if there's a Java project, what kind of Java project are you talking about? J2EE, or you're trying to develop some kind of plugin, just quick start, a site, or whatever. So I'm going to choose a quick start and click on next, and I give an ID and project name, 4800 demo. All right, and now I create this one here. As you can see, this time, the moment I open this folder, it has already the folder called main.java, as it's test Java for the test purposes. It has the Maven dependencies, source folder, target folder, and then there's the POM file. Okay, so compare this one with this one. As you can see, this one is much more structured. But this is only one example. If you're trying to create a Maven, for example, web application project, it will probably give you a more detailed specification, separation of the folders for different files. All right, so that's why using the build tool, it helps you to kind of standardize this whole thing, because we don't want to have different people or different team to use their own standard to put their files. For example, I want to create this text file, the test file into this main test folder, and then different person want to create it, just put it in something called a test. All right, either way makes sense, but how can we work together if we don't follow the same standard? Right? So that's basically why we need to rely on a third-party tool that gave us this structure, so everybody will just follow it. So if you're open most of the Java open source project, you will find that this Maven is widely used, and they all follow the same thing called main Java and the main test or something like that. So the folder are unique and standardized. Okay, that's one really important purpose of using the build tool. So again, the tool we're showing you here is Maven. It's specific for Java project. For different project, you will have different kind of tools. A very good example about Node.js is you have this npm tool that helps you to also do the same thing. You can have npm initialize to create a project and give you a standard folder. That's exactly the same idea. All right. This is a very typical Maven Java project structure. So you got a project folder, you got a source folder, and source folder you can have a main for the major source code, and you got a test folder for test files. Another important thing to have is something called a POM file. Okay, so this POM file is a core specification file for your Java project. All right, so the POM file specify all the metadata information about your project. So let me open the POM file to check. So if I open here, this is the POM file. As you can see, it's very font size is very small, but basically it's HTML kind of a base file that has the version number, group ID, the project group ID, and the project name, some of the version of the project, and package, what type of package you're using, and then you are using, give a name, a URL information, some properties, and eventually you got some dependencies right here. All right, so this is a kind of a meta specification for this whole Maven projects. All right, so with this one, the Maven tool will be able to know how do we build your project, and then how do we bring the dependency and everything. All right, so that's how the Maven works. All right, so the POM file, if you see that, you should know this is a Maven project. All right, so that's the first function I want to talk about the build. It's a standardized project structure. All right, very easy to understand. Otherwise, we do not have a standard on where we put the file and everything. That's why for your team, you should actually stick with one build tool. Depending on the framework, you should have some kind of tool to help you to manage the same thing. And then set up that tool first so that the whole team will be following and using the same kind of standard to put their files. All right. So that is the first function of the build tool. Really easy. If you use a tool to create a project, you will have this kind of standardized structure, right? Number two, about dependency. This is really important, and this is probably the most feature about Build 2. When you are working on your project, you will need to write a lot of code, but not all the code you have to write by yourself from scratch. We often bring and borrow third-party libraries to our project so that we can take advantage of their libraries. The best example would be, for example, Java Spring. I talk about that one. It's a very complicated web framework that's been built for 20, 30 years. But there are millions of lines of code, but then we do not need to worry about how to write them. We just need to bring them to our project and then use that one as a dependency, all right? So when you are borrowing the code, all right, so there are different kind of challenges. Number one, where do you get those code? Do you know the right place to download it? And secondly, how do you manage a version? Because every dependency will have some kind of different version, and then they keep updating. Do you always stick to the most up-to-date version, or you need a specific version for some reason, right? And then the dependency could become even more complicated. For example, you're depending on this one, and this one depending on another package, and this package depending on some other package. However, when you are depending on different package, it turns out to be some of these sub-packages also relying on the same package. All right, so again, if the version doesn't matter, that's always preferred. However, if it does matter, for example, this guy only works with 1.5, and this guy only works with 1.6, how are you gonna do it? All right, should you keep two versions there, or can you actually use one to replace another one, or downgrade one version? This whole dependency could become really complicated, especially in big companies. Most of the projects rely on so many different things, and you will find it really difficult to manage it sometimes. All right. So in order to manage this one effectively, we use Build 2 to help us. All right, so I'm going to show you one example here. All right, so I will like to use this Java dependency called JSoup. Has anyone used JSoup before? So this is a web scraping library from Java. So you can kind of scrape all the web pages. I'll give you an example here. All right, so they gave, you can just go to the web page, for example, Wikipedia, and then you can try to get all the tags from the page and then just show it. All right, so it's a web scraping. So let's run an example and you will know what I'm talking about. All right, so this is a Java library. So you can see they provide document, elements, and then all of this. All right, but this is a third-party library. So for example, if I get all this code to my code here, okay, I'm gonna go to, let me try this one first. I'm gonna go to a non-Maven project first, like this guy here. It's a plain Java project created by Eclipse. So I'm gonna copy all the code right here. And immediately you see that this one doesn't work. Okay, so this document, JSoup, these are the external library we don't have. All right, so what we do, we need to bring a dependency because it's coming from somebody else's code. So what I do here is I go to this website, I find something to download. All right, I can find this jsoup.jar library. And all I need to do is just download this one here to my machine. All right, so I got this jar file. That's where all the class files are in. Back in Eclipse, I can then go here. I will say create a new folder. I'll find a place to put my jar file called the library. And then I will copy this jar file over to the library folder, put it here, right? And also I need to configure this as a project to say that I need to add actual dependency in the libraries. I need to add something here. Add a jar, click and choose that jar file I just added. All right, so now I have an actual dependency in JSoup. So go back here and try to import them, and I can find JSoup element, JSoup document, and another JSoup class. All right, as you can see, these are all the JSoup dependencies. And then from here, I can do it. So I don't know where the log come from. Okay, I'm gonna change it to this print statement. Does anyone know about this log? What's going on? Is this a new Java feature or whatever? Why in an example they show a log? Anyway, so I will just use the print statement. Exception. I just need to throw that exception. All right. So here we go. Let me first run the code and you will know what it does. Okay, so run this code here. Oh, it doesn't find the JSoup class. Interesting. I already configured the definition here. Okay, so let me redo the build pass. Maybe the class pass. All right, so let me try this again. Nope. Let me see. I think that's the right way to do it. Somehow I need to import this one here. Try. All right, so let me double check maybe the. Oh, really? So there's a, what's the file name called a model info file? Yeah, that's kind of really a lot of a new changing right here. Yeah, so this is the JSoup class, right? Or should I downgrade my Java version just to make it work? But I don't know if I even have a different version. Let me see. Yeah, but previous normal, I just do model pass. All right, so let me try this one here. Migrate jar file. What does that mean? Yeah, it's kind of a pain. So let me recreate another one just to make sure I'm doing everything right. So I got a Java project. Let me do another one here. Just Maven project without Maven. Okay. Are we able to get an older version? Let me try that one just to be safe, or if that can help us do something. All right. All right, let's try this one more time. Okay, so I'm gonna get another project here. This time I use 1.8, not sure if that's gonna help. And then I'll copy this code over. So this won't work. And then let me create one more folder, libraries, and then copy over that library to here. Okay. So, and then eventually we specify the build path properties. All right, so this one looks more familiar to me. I think Christian was right. There's something about the model info. I'm actually not very familiar with that. Let's try this. Okay, see if we have any luck. All right, now if I run this one here. All right, so this one does work. Okay, so it probably will has something to do with Java 14, some other requirements. Okay, so let's not worry about it. But I'm actually showing you how you can manually add this dependency jar file to this project folder here by configuring the build path, including a jar file, so this class will be recognized. So what this does, as you can see, it actually go to your Wikipedia page and then grab all these A tags and then grab all the title and also the hyperlink. So this is the web scraping page tool that, you know, if you go here, for example, let's go to the library. All right, and then they are actually looking at this part right here. So how can you grab this one? Because essentially these are all the HTML code. So you can look at the type of tags here. Under the B tag, there is an A tag, and then we grab the title and also the link. So that's what you're seeing here when you print and everything. Okay, so if you're interested in JSoup, you can take a look. But here I'm just showing you the JSoup with third-party library dependency you bring in. But that whole process, you can see, I even had some errors, and just because configuring all the libraries, it takes a lot of time. But then if you use Maven, things will be a lot easier. All right, so for example, I'm gonna create this one here. This is a brand new class without anything. So I'm gonna get the same code to the other project where I have a Maven set up. All right, so I'm putting it here. And you can see this class still not recognized, and because I don't have dependency, just like this project initially. However, if you have a Maven project like here, you can just do a specification in a POM file and then specify what kind of dependency you need. All right, for example, here, you have a folder called dependencies, and you can put as many dependencies you want. All right, so I go back to JSoup file webpage, and if in the download page, you will see there's something called a Maven, and they gave you this little tag specification, sets the version, the group ID, and also the package artifact ID, and then the version name. So if I simply copy this one over and then put it here, all right, add a dependency. Now, later on, once I save this file, I want you to watch what happened. All right, so right now, here is the Maven, only one dependency called JUnit. But the moment I save the file right here, I'm gonna click on save. As you can see, it automatically downloads this JSoup jar file and then put it in this repository here. And also it configure all the dependencies. So this one here just work automatically. And all I need to do is just to fix this exception, and then I can run it. So this way I'll get exactly the same result. But the difference between this project without Maven and this one is using Maven is so much easier to bring a package into your repository. All you need to do is specify it, and then they will help you to download it. They will help you to configure all the build paths and everything. You don't have to manually create all of this. Even cooler thing is the version. So for example, I don't want to use 1.13.1. I want to use an older version, 1.12.1, for example. Right now it's still 1.13.1. So I'm going to save the file, and automatically this one will be updated to 1.12.1. And I don't even need to think about how and where we get this library. And it's all in that centralized Maven repository that, you know, have all the published libraries. So managing the dependency using Maven is really important and very, very efficient. And also for all the other tools, for example, you use Node.js, the package.json file serves the same purpose. And anytime you want to bring a new package, you will need to specify the version and name in that file and then get it up to date. All right, so now if you open our 480 demo project, so if I go here, and then if you look at the POM file, as you can see the dependency, you got so many other things. You got Spring Boot starter, JSON pass, JUnit, all of those different kind of dependencies. And then that's why here you have so many different jar files. Okay, so we didn't really manually copy any of these. They all come from Maven build tools. All right, so that's how you can manage the dependency. Again, I'm only showing you how the Maven works, but all the other tools work exactly the same idea. It's just different syntax, different specification. They all have some kind of remote repository that save all this dependency in the files. And then the moment you specify it, it will try to download those to our local repository and then use for different projects. And this is the very standard way to specify dependency, but only for Maven. If you don't use Maven, you have to look at other specifications. For Java, another popular one is something called a Gradle. If you've been doing Android development, Gradle is more commonly used. It's a newer version of the Maven, but I think they still share a lot of the backend together. All right, so this is about dependency management. Really straightforward, but very important. You shouldn't do any kind of the manual management using by yourself for the dependencies. Always rely on a build tool. All right. So some of this new frameworks such as Node.js, you can't even manually do it. You always need to do the command line npm install that's safe, and that's how you manage all the dependencies. All right. But the idea here is the same. So third function about the build tool is how can you package your software and then to make it more deliverable. So let's say you're done with your project and then you want to run it somewhere. Then you want to send it to a server, for example, for a web application. But how can you send it? All right, so right now, again, go back to this example. The 480 project, and this is not a lot of code, but it has so many dependencies, so many Java files, a lot of web pages, right? If you're trying to run this in a different server, how can you do that? Now, one way you might think is, why don't I just copy the whole folder or make a zip file, copy it over to the different machine and open a different machine in Eclipse and click on the button to run it. Just like how we run it right here. I run this file and it will just trigger the whole process, right? That one definitely works, but it's not professional. And also a very important thing to keep in mind is most of the server, you don't even have the graphical UI. So you can't run Eclipse like this. There's no run button. Everything had to be on command line, all right? And also, if every time you had to manage this many files, it's just not very convenient. Ideally, can we just get one file and make that one file executable? Just like you download some kind of application for Windows, for Mac, and just one file, double click and run. So that's the ideal case. So for most of the software, when you try to deliver it, you should try to deliver it in an executable format and with one file only. That's always preferred. So Maven can help us to do it, all right? Maven, actually not just Maven, all the build tools, they will have different ways to do it. For Maven, for example, you can run command something like Maven package. It will actually generate everything for you. All right, let me show you this one. Again, this is currently how we run it manually through Eclipse. Try to right click on the button. All right, but if I go to, for example, command line, let me show you. So here is the project. All right, and I'm going to run this command called Maven. So this is how you do things in command line. Most of the build tool you probably have to operate it using the command line. I do Maven space package. All right, as you can see, a lot of things are going on. This is how they build the software. And if you briefly look at the text here, they're trying to build this whole project. First of all, they do some of this default resource setup. copying the resource files. They compile Java code. They compile the test code, and they run all the tests. There's one test that passed. We'll talk about tests next time. And then after that, we build the jar file right here. Eventually we're done and build success. So what does that mean? After all of this, right? So there is a folder here called target folder. I go to cd target, and you can see they generated so many different things. One of the important files is this jar file. And then I want you to see that this jar file, you can see the size, it's actually 70 megabytes. Now, obviously, we didn't write that much code, but this one has everything. It has everything you specify here in the folder, including all the dependencies. That's why it's that large. So this one file only is a file that you can use to deliver and also to execute. Can anyone tell me how do we execute a Java jar file? If the jar file is executable, what's the command? How do we execute? All right. Oh, very good, Marcus. Java-jar and then CS4800.jar. Obviously, you need to install the JDK first. All right, hit enter. All right, so as you can see, I'm running exactly the same thing, the same output right here in my terminal. And I go back to my browser localhost 8080. And this one works the same way. All right, so I think we've got some home AGS thing. All right, so this one still works. Just like how I run in Eclipse. And now I'm doing that in the terminal. All right, but you can see the difference is this time I only need this one file. In the future, when I show you how to deploy your software, all you need to do is copy this file over. That's it, and then you can run it in a different machine, as long as that machine has the JDK installed. All right, so that's another purpose of this build tool. You can package stuff, you can make things archive or executable very easily. All right. So same thing for other tools, and Node.js, all other, they also have something for you to do to package it. All right. All right, that's how you kind of run your application. So make sure you know there is this target folder. Okay, so the target folder will has a lot of the things generated by build process. Let me see how we can synchronize this one. Refresh. All right, so it has a lot of different files coming from the build process. All right, so most of those we don't need to use right now, but sometimes you will touch this folder and see what's generated. All right, that's the third feature of the build tool: execution packaging. So lastly, you can manage the life cycle. So what does that mean? So when you are building the software, let me run this one more time. Okay, so I'm gonna clean this one. I will do a Maven clean, and then it's gonna delete everything, all the folder. As you can see, we don't have the target folder. This is just sort file. So I'm gonna run this Maven package in. Okay, pay attention to all the steps going on one by one. All right. So as I showed you, they have a compile all the code, compile test code, run test code, generate jar file, and do some other replacing main artifact, all of those. They do a lot of different steps, just like a pipeline. They do that one by one and finish all these tasks. All right. So these are different stages when you are building the software, from the validating, make sure the files are okay, and then you compile them. Then you run the test, and then you generate a package, which means you generate jar file. And after, you can also do something else like verify, integration test, and install and deploy all of those. All right. So for example, let me show you. So after you do the package, if you go to the target file, you see you have this jar file generated. That's what the package does. But if I let's see that I do a Maven clean to delete all this folder. This time I do a Maven test. All right, if I do Maven test, it will compile and run the test. That's it. It will not generate that jar file. So I go here, I go target. As you can see, there's this no jar file generated because I specified a Maven test, not a package. because the package will generate jar file. Test will only run the test. And if you do only compile, it will only compile your code. It doesn't even do all the other things. So this Maven command, all right, space, what you type here is something called target. Okay, what is the target lifecycle stage you want to use and you want to try? And depending on which one you specify, it will go all the way from beginning to that target. If you do test, it will all the way from here to test. If you do a package, it will get into here. So you have the flexibility to choose what you get, where you run, and then how many steps you want to run. All right, so pretty simple. And from you have to compile first, and then you can run the test, and all the tests pass, and then you generate jar file. Once you generate jar file, you can then do the install and deployment, all of those, right? So that's how we do this management. But I do have a question here that you see here, you can go to the different destinations. But then you see that if I do package, it actually covers everything beforehand. Okay, if I do package, it run test, run compile, all of this. Why do we still need to run the previous stages separately? Why don't I just always run package to go through the whole thing, so that I can make sure everything runs and still generate jar file? What is the point of supporting running all the other stages? If you want to run test, that's fine. You know, just do package. It will generate everything and still run the test, right? Why do we ever need just to compile it only? What's the point? Anyone have an idea? Let me repeat my question. So I'm here in the Maven folder. I can do Maven package. So this one goes all the stages, compile, test, and jar file, and then main method. But I can also do Maven test. So this one goes a little bit less steps, doesn't generate jar file. I can do Maven compile and only compile stuff. That doesn't even run the test. The reason is because I'm actually, targeting different stages, so it will only go that far. But why don't we always go really far to package so that it goes through every single step? Yeah, so if something wrong in the middle, it will capture it. All right, so for example, if your code doesn't compile, when you run the package, it will not go there. It will fail. For example, if I bring a little error here. Okay, let me go to 480 project. All right, so I got a compile error here. All right, so I do Maven package. Obviously, if I do compile, it won't compile. Oh wait, it compiles. Is this the right file? 480. Let me clean it. Okay, I don't know if that's the reason. Maven compile. Okay, so it fails because there's error. But if I do Maven package, so it will still fail. It will stop right there. You can't really get to this package here. All right, so if something fails in the middle, you will see that. All right, what does it mean, Jimmy, unit test? Same thing, if you run the package, it will cover all the tests. So why does Maven still allow you to go to individual stages there? Why don't we provide a standardized thing, just go and already run all of this? And Andrew, what do you mean for debugging? All right. So for those of you who probably done some big project in a big company, you will have a better feeling about this one. All right. So the reason is sometimes if you run a package, it's going to take hours. All right. You just can't afford to run that. Now this project is super simple. You run it, just takes 10 seconds. But I can tell you in the Amazon, in the regular web services, there's a whole complete build process. It takes, I think, 1 to 2 minutes. That's a very, very typical. You basically, you make minor changes, you want to run, test something, you just wait for 1 or 2 minutes. It's a very, very typical in that way. And the web service is okay, not really the most complicated project. If you ever work on an Android OS change, for example, if you're building your own Android OS, you can get all the source code. You want to run the build process. I think you get a very good machine. 5 years ago, I remember a really good machine to complete the one build. It takes 45 minutes, all right, for everything. But you are developing or making some minor changes in this huge code base. You definitely don't want to go through that far every single time. You should try to go to a very specific steps. For example, test. I only want to test that one file. So you specify really specific target. Just run that one for me. Just because you cannot afford waiting for running the whole thing. So this is something you don't see very often at school, but once you go to a big project in real industry, you will realize that the projects are just too complicated. The build process takes forever. And then that build process is so much more complicated than the one we can demo it here. So that's why giving you this flexibility is really important. Okay, you just cannot afford to go to here every single time. All right. So these are the quick overview about Maven tool, but the same idea applied to any kind of build tools. So for your project, you must use a build tool, okay? I know for Node.js it's NPM. I'm actually not too sure about Python. Still today, I'm not too sure about what Python uses. It was a package something. And but every language do have a build tool to support. It's just a matter of how complete it is. The Maven is really a very, very standardized tool that has all the single concepts. So that's same thing for Java. So as a language, Java includes most of the modern programming features you can ever think. All the other newer languages just take advantage of that and make it easier. Same thing. Some of the NPM I think is a lot easier to use compared with Maven. But the idea all comes from this Java world. All right, so this is required. The next assignment is going to be applying this build tool into your project and make some changes. So you are required to add some dependency there and to use that dependency to write some code and to push it to the repository. All right, so that's the topic I want to cover today. Any questions? All right, make sure you guys organize some good team meetings. All right, and we don't have that many weeks as you saw to finish the project. You probably only have about 8 weeks, 7, 8 weeks or so, less than 2 months to finish it. All right, we need to have a very nice demo. We also need to deploy that and start early, okay, before you get too busy. All right, very cool, guys. If you don't have any questions, I will see you next week.